So this is the second portion, design and implementation of an intelligent prognostic systems. So you see, these slides was prepared 10 years ago. In other words, about 12 years ago, I have already finished the design, and this is a material for teaching how to implement this kind of intelligent prognostic systems. Okay, so introduction and abstract. I think you know this one already, right? So this is the e-manufacturing hierarchy. These are manufacturing portion, that are engineering portion. So you see here, and the process equipment, and you see we have connection here. This is implemented by interface A, because we need to collect a lot of data, the equipment data, through interface A, so that equipment engineering system can do, for example, FDC, AVM, etc. While this portion is implemented by SexGem. Okay, so see, this is manufacturing portion. That is the engineering portion. So you see here, yeah, this is interface. Interfaces for equipment for e-manufacturing. So an equipment has two ports. One is the SexGem port connected to the MES here. Okay, and the other port, that is the interface A port. This interface A will provide the equipment data to the equipment engineering systems. And actually, they do. So you see, we have SexGem. That is the primary equipment control interface. I/F is interface. While interface A is equipment data interface. We are getting more and better data from the equipment. And then the interface B will define the applications and the two FICS and MES. MES, this is the MES. FICS is file control system, equipment, factory control, factory and information control system, something like that. And this is MES. So you see, what I mentioned to you before. Did you remember? The EES is trying to support MES. So we do have a communication here. And this communication, how to define it is interface B. But actually, they didn't define it in detail. They just have this kind of concept. So don't worry about interface B now. Don't worry. But you need to know what is interface A. That is the EDA. I just taught you during the last section. But while we have interface C here, this is an external access to e-diagnosis. This is external e-diagnosis. But this one doesn't been defined any further. Also, just because if you connect these kind of connections, then 电脑骇客 will say he may steal some kind of secret from this kind of connection. So TSMC won't allow his vendors to have this kind of connection. So for this picture, just worry. You just need to know about the SexGem and the interface A. That is good enough. Okay. So what is SexGem? What is interface A? So you see, this is an interface A EDA concept. So this is something similar to what I emphasized to you previously about the scenario, the single or engineering data exchange scenario. So you see, this is equipment, and that is the client. So manager section, consumer section, etc. So we will use the E132. Just a second. F9. So we will use 132 to define authentication and authorization. Okay. Then what metadata is available using E125 is equipment self-description, right? Then E125 available data structure. and how to define the equipment data model using E120 and define control of report, right? But the last last figure is better than this one. So if I asking you about interface A scenario, use the last one. Don't use this one to explain it. Okay. And this is just give you an example. Assist is a company. So you see each tool has 2 ports. One is for SexGen, the other is for interface A. So that is just give you an example. And this is the equipment engineering system. So we have APC and SPC and FDC, run-to-run control, etc. And so abstract. So the proposed IPS, what I try to tell you is the genetic embedded device. So let me show you this one. IPS, you see, use this picture to explain it. It will be more easier. So we have equipment, and we have a built-in genetic embedded device. So this is, you see, about 12 years ago, at least 10 years ago, I have this kind of concept for genetic embedded device. This embedded device, at that time, I designed this one for predictive maintenance. And you see, this kind of device embedded into the equipment. And then the client, the remote client, can access this embedded device via internet. But right now, of course, this becomes the cloud computing, right? But at that time, 10 years ago, we don't have cloud yet. So, but anyhow, the concept 10 years ago, I have already defined this kind of concept here. So you see, this genetic embedded device it's embedded into the equipment. So let me see what's going on here. So this is the IPS. You see, the equipment has an embedded GED, and this one will communicate with the outside world, the remote client, through the SOP. You see, 10 years ago we know SOP already. So you see, this is a communication agent to communicate with each others. And you see this GED, we have a PAM here, Programmable Application Module, right? So the GED, how to collect the data in and out, just use the concept of interface A to collect data and send it to the outside world, or collect the data backward, send back to the equipment. But if necessary, we can collect the data and send it to the Programmable Application Module to do the smart application, what we call the smart application here. So you see, this is some kind of device for what we call an IoT, Internet of Things, because you can use the you can send this data through the internet to the outside world. But 10 years ago, we don't have IoT, this kind of term. But anyhow, you see, this kind of concept is very good for defining an industry 4.0. Okay. So you see this PAM. So I will give you example because this will give you the smart application. So this smart application can be something like predictive maintenance, or even virtual metrology, or even, for example, in CNC machine tool, for CNC machine tool, this can be for tool wear detection, 就是刀具磨好了 tool wear detection, etc. The application can be implemented in this portion. Okay, so then let me define what is GED and how this works. So GED can be installed in various information equipment to receive, correct, manage, and analyze the data, and then utilize the communication module of the equipment to transfer the data to remote client via wired or wireless internet. So you see this definition. The IoT is about the same, right? So 10 years ago, I have already published this idea. And of course, I have a patent for that. And you see, GED is equipped with a pluggable application module, which can receive equipment engineering data from GED to execute equipment engineering functions, such as predictive maintenance and quality prognostics. So you see, this kind of pluggable application, right now, we can treat this as an app of your cell phone. For example, the iPhone or your HTC cell phone, right? You can write an app and download it from the web, download from the outside world, and download it to your cell phone, and you can run it. So it's a kind of smart application. 10 years ago, I have already defined this one, right? So you see, GED basic functions. So I just use E120, 125, 132, and 134. It means I use the EDA standard to do the equipment. I should say to do the engineering data exchange, and etc. I should say, besides, I still provide with a plug-in PAM modules, equipment drivers, and the CEM functions. So what it is, you see here. So this is the GED architecture. So you see, I implement 120 and 125 use this equipment driver. Okay, then 132 to that is the authentication and authorization for taking care of the security. And then here 134 is for data collection manager, data collection plan, data collection report, right? But this portion, intelligent prognostics kernel, you see I define an application interface so that this pluggable application is a plug and play, interchangeable. In other words, if you have different application, you just plug in different modules. And you see this here, this one can be plug and play. So you see, if this is your cell phone, and you can download the application and plug it in, and you can do all kinds of application you want. So you see, this is intelligent prognostic kernel, and we have a patent for this one too. So you see, so communication agent, this one, we just mentioned to you about 132 for authentication and authorization, right? So this communication agent using SOAP protocol to deal with the request of remote client and reply to it when needed. So communication agent adopt SEMI E132 specification, and you see how to do it. So to begin with, to establish section, right? We have an administrator here, so establish sections. So you see request, then send it to establish sections, then do authentication and authorization, then do data collection and data reporting, and then close the section. Okay, so 10 years ago I have already know how to do this one. So IoT, I have already done that. Not necessarily just now. 10 years ago I have this kind of concept to do the IoT, because IoT security is very important also, right? So you see, then the DCM, data collection module here, a data collection manager. Data collection manager using 134, right? So how to do it, and we have add, delete, activate, deactivate, etc. So you see, so how to do the data collection module, you see, we have defined plan, get defined plans, etc. This one are defined in the interface A. We just use that function, that concept to do so. And then you see this portion, the GED module, use this portion to define. Then you see the GED module, the DCM. We have three kinds of data: event, trace, and exception. So after define those three kinds of data, I put it into DCP, and then the data collection, the remote client will send the data collection plan to the data collection manager. Then the data collection manager will prepare the data or data collection report according to this data collection plan. After finishing collecting the data, the DC report, then it will send through the data collection manager back to the remote client. Right? So this is the scenario. Then how to define the CEM and ESD, the common equipment model and the equipment self-description. Then how to define the feature, the parameters of equipment according to CEM and ESD is this portion. Okay? So you see, CEM and ESD, just use this. This is CEM, this is ESD. Use that one to define. So you see, did you remember the ESD will define this method, right? Client will access this method through the metadata to do so. So you see how we can do so to create a new data collection plan, then activate data collection plan and data acquisition. Then we have exception hand warning and multi-client and multi-TCP flow. So you see, create a new data collection plan. Then create a DCP. Okay, then send DCP to the GED. Then DCP is saved. Then you see, activate data collection plan and the data collection, data acquisition. So you see, remote client send and activate plan and initialize the equipment driver, and then create data collection report. Okay, then get equipment data and report the equipment data. Okay, so then exception warning. If you have exception, then this one will send through the data collection report and send it back to the client. And the multi-client, multi-TCP flow. So actually, GED not necessary to just have one client. You can have multi-client and you can have multi applications. So you see here is GED. We have PAM. We have 3 applications here, 3 equipment driver and 3 CEM. We can do it simultaneously. So multi-client connect to GED simultaneously. Then you see we have remote client 1, 2, 3, 4. We can have multi-client to do it. So you see this is very good architecture to do intelligent prognostic systems, because complicated equipment may have so many devices in one equipment. So each device needs a prognostics or need a predictive maintenance software, and we can do something like that. Okay, so remote client simultaneously activate multi-TCP and then support, and then you see this is remote client activate multi-TCP. Then finally, the GED supports the functions of plugin APP equipment and the CEM. So you see this is supporting plugin, not only the APP but also the equipment and the CEM. So you see, so this is the scenario of multi-client and multi-TCP flow. So if we have 2 clients, the first client send a request and it will activate the RC1, remote client. RC means remote client 1. Okay, RC remote client. Remote client 1 activate and TCP, and remote client 2 activate the other TCP. Then data collection manager scheduling for TCPs. We have 2 TCPs, right? Then prepare the report or remote client 1 and prepare the report or remote client 2 and send it, of course, report it back. So then the PAM, this is, you see, 10 years ago I have this kind of patterns. So you see, GED is equipped with a pluggable application module which can receive the equipment data from GED to execute detection, diagnosis, and prognosis, etc. And so pluggability is the main advantage of PAM, which can use DLL to implement various application programs. You see, so I define this one, so it's just the same as what the app is defined, the cell phone, right? So I have this kind of pattern 10 years ago, but I don't have time to shoot the Apple, Samsung, because I have this kind of idea 10 years ago. So you see the pluggable application module. The application module in the GED is designed to be pluggable for different requirements. And this PAM can accept system parameters or messages sent from the remote cloud host. The PAM can send the exception alarm message to the remote host when an exception alarm is detected. So two PAM names, and I use the two examples. PMS, that is for intelligent predictive maintenance, and virtual metrology. But of course here I just use the predictive maintenance will be enough. Virtual metrology I will defer maybe 2 or 3 weeks later. Then we'll teach you what is virtual metrology. So the design of PAM. So the PAM must be able to receive the messages sent from the remote host via the CA, the communication agent, and send the exception or alarm to the remote host through the AI, and when the PAM detects a fault. Okay, and in order to dynamically plug the PAM into the GED, a genetic AI is application interface. AI is application interface must be constructed first. So various types of PAM can be plugged into the GED, and the DCM for the remote host can communicate with the PAM through the methods supplied by the standard AI, right? So the AI is defined by a standard. So you see the design of PAM. So if user would like to develop a new PAM for special equipment requirements, they only need to follow the methods specified by the standard AI and implement them in the new PAM, and then the PAM can be plugged into the GED. Then the second one, for plugging the PAM into the GED, we may pack the PAM in the types of dynamic link library. We can use dynamic library, ActiveX, COM, etc., and add it to the PAM directory. So you see, we can, for example, for the cell phone, then you can, if that is Android system, then you will use Android interface to design the app. And if that is iPhone, then you just use iOS to define it, right? So the interface, genetic interface is very important. Okay? So the requirements of application interface, that is the AI. Okay. The application interface must be able to transfer equipment parameter data from the data collection manager and to the PAM, and transfer the prognostics result to the DCM, and receive the prognostics trace requirements and the PAM parameter from the remote host. Then respond to the prognostics trace requirements of the remote host, and finally send the exception or alarm messages to the remote host. So you just use this kind of concept to design the AI, right? So this AI is genetic. You can define your applications, your smart applications, and if they can follow the AI, the application interface, then he can plug in the module and let it plug and play. So you see the process of PAM. You see, this is pluggable. Actually, the equipment driver can be pluggable also. And the DCP, you need to prepare the DCP. So initialize PAM. To begin with, initialize PAM. We need to plug in a suitable PAM and define a suitable DCP. And then the equipment driver, you should plug in a specific equipment driver. For example, that may be Sex1 using the RS-232, or they may be use TCP/IP using the HSMS or interface A, right? So the second one, then DCM loads the DC plan, then DCM gets equipment data, then send equipment data to PAM, then PAM processing, then send result to DC report, then send message to the remote client. Okay, so that's it. And of course, after knowing, you see, I have already teach you how to design an distributed object-oriented system. So, but this one is simple. You see how to define. Or if you know all the requirements of the GED, then you will draw the use case diagram. And you see this use case diagram, you see the GED can perform authentication and authorization and correct data collection plan, etc. And you see here we have a pluggable application. You need to plug in and pluggable application interface, the AI. So then the usage of GED, those are pluggable. So creating a new DCP, then how a new DCP can be created? So you see when a user creates a new DCP or selects a DCP from the DCP list and processes the button activate DCP, then the GED will retrieve equipment data according to the plan of said DCP. So you see the data will be sent to the DCM, data collection manager, inside the GED through the GED equipment driver, and DCM will store the data into the DCR according to the data types and the format defined in the DCP. So besides the DCM will add a timestamp to each data set. Be careful. The timestamp is very important because if you like to know what's going on there, you always need to know when this kind of data being collected so that you can have mapping the cause and the effect relationship. OK， 就是因果关系的，你要把因果关系逗好，时间很重要，所以一定要有个 timestamp。OK， so you see, this is the GUI of creating a new DCP. OK, so you can select all the parameters you need. OK, and what kind of data collection plan you want. Did you remember when we define the scenario? Then the equipment supplier will provide the metadata to you, right? You just according to the metadata, that is the manual. Then you just select the manual, the preferred data collection plan you want, the data you want. So after you define, then you can store it and name a data collection plan here. Okay. The second one, the GED initialize the GUI. Okay. So you see, it just try to select. That is this is common equipment module, right? And it's equipment driver and the PM. Those three can be defined, and just send it. Click in here. Okay. So send all the data. Data collection plan manager. So get data collection plan. So you have so many data collection plan here. So just choose the one you want. So you, for example, this interval is 10 and 100 milliseconds. What it means is 0.1 milliseconds. So you see, after you have this one, then of course you can activate it, and then I will show you what's going on there. So you see, we have already implemented this 10 years ago. And you see, and this will show you how to define a security administrator. So remote client, and how to define a remote client, to define the security. Okay, and this will give you the remote client GUI. And then this give you the multi-DCP and multi-remote client scenario. So you see, we have remote client 1, remote client 2, and then this is a security administrator. So how to establish sections? Did you remember in the last section, what I tell you, just have single client. Here we have two remote client. Okay, so you see two remote clients. Then we need to establish two sections. Remote client 1 to GED, remote client 2 to GED, and establish the section for remote client 1 and 2, security administration. And after get the authentication, and give him the permissions. Then remote client 1 and 2 can send and get PAM, get driver, get CEM, and so that he can communicate with each other. So all these kind of scenarios been defined and successfully implemented in 勤路自动化. At that time, we implement this one in 勤路自动化. Okay, so you see how this works. Then I will show you this video, multi-TCP, multi-remote client demo. Okay. So to begin with, to have administrator log in, so it will define the user. So you see remote client 1, so it defines the remote client 1, and then the remote client 1 will get the app, the equipment driver, etc. so that download it to the GED, so that he can have a specific application or smart application for this remote client 1. Okay, after register this remote client 1, you see he try to get the equipment driver. Okay, then this is multi remote client. Then you see try to get define a data collection plan, and you see activate this data collection plan. This is PAM1 platform application. So you see it's running. You see, so at that time you see this is the predictive maintenance for the conveyor. So you see this just have 0.1 second. I should say 1 second. The update rate is 1 second. Then he tried to activate the second one, activate the second remote client, and he will have a data collection plan. Then this one will be faster. It will have 0.1 second. 0.1 second. So in other words, 10 Hertz will be faster. So this is very slow. Update rate is 1 second. Then you see he tried to get a data collection plan. Okay, and this data collection plan is number 5, and you will check with that. Then you see the interval is 100 milliseconds. In other words, it's 0.1 second. You see this one is a lot faster, 10 times faster, right? So you see this is faster. So I just show that we have two clients. One update rate is 1 Hertz. The other is 10 Hertz. So we have two clients to activate the GED and to collect data and do the application simultaneously. Okay. So after finishing this demo, and you see I can delete the remote client 2. You see remote client 2 has been deleted. Log out. Right? So log out. So user 2, RC2 just gone. Then just remote client 1 left, and we can delete or delete the remote client. I should say delete the PAM1, the DC plan, deactivate it. Try to deactivate it. Okay, right? Deactivate it. Push it. Then PAM1 will be deleted, right? And then the RC1 will be deleted also. Okay. So you see, try to log out RC1. Okay. So that's the demo. So you see this kind of scenario, this kind of application, we know this one how to do it 10 years ago, but it's still working. They still can have this kind of idea to design your IoT. Okay, so illustrative example, the predictive maintenance system. You see, I just show this one in the last section. So the predictive maintenance shown this one. What they would like to ask us to do is the scratch of the glass. You see, so how to check that we don't need a scratch of that? Is we need to know. Let me show you. So you see, I have already shown this conveyor layout. So how to do it? You see, we have photo sensor here, and we have motor here. So we need to detect the abnormality of the photo sensor. Photo sensor may stick on or always off. So we need to check that what's going on there. So, but you see, we have a standard or the healthy pattern, and using that pattern as a reference, and compare with the standard, with the standard, and to check that this sensor is healthy or not. And the motor, of course, we will check that the speed is within the tolerance or not. If not, then the speed is changing, then something wrong there. Okay, so you see, this is the predictive maintenance system. So you see, this is pluggable application, and it's PMS, the pluggable application. So you see, we need to install the sensors to check the conveyor, the sensor data. You see, check the conveyor, the sensor information, and I mean the photo sensor on-off information, and a motor current. And those motor current will be converted through the A to D converter and correct it into the system. And of course, we need to check the PLC logic to know the time sequence, right? So this data, we'll put it in here. And you see this data, we have references of sensor states and the motor speeds, right? So we need to have a healthy reference put in here. And we need to correct the reference shown here. And then after correct the data, we should know what is the reference. And after pre-processing the data and training the model, so this is the basic model, put it here. After training, then during running, and if you have data come in, and we have reference shown here, so we just compare those two. You see, compare photo sensor status and the motor speeds. If they are the same, so it's healthy. If not, then something wrong there. So you see, find error code and the location if an exception is detected. So you see, just use this kind of physical meaning. We try to find the cause of the exception and the error. So you see, after finding out the cause, then it will trigger, it will send the alarm out. So that is the predictive maintenance. So you see, according to this kind of application, and just convert this one as an application module, app, or pluggable application, and right, you see, then you can plug in here to be the predictive maintenance application. Okay? So this is a very typical example, a very simple example to tell you how to design the application module, I should say the pluggable application, to do predictive maintenance. So you see, this is what we really implement, the PMS development. So you see, this is the PLC, and this is the A to D converter. Here is the A to D converter hidden. Okay? And then this is the single board computer. Right now, we just use Raspberry Pi, just about this size. 10 years ago, it's a single board computer. It's about this size. So you see, these models are implemented in here, right? And this model just what I tell you. We have a pre-processing of data, and then a preference, right? To compare something like that. So this is the predictive maintenance model here. So you see, we have a host with the equipment, and that is the PC. So you see, after we explain this one, we know that we have two phases. Phase 1 is doing training. Phase 2 is running. Phase 1 is we need to collect the healthy data to prepare, to establish the standard pattern. So you see, after collecting all the data, so we need to establish the PMS reference. That is the model. So after identify that this is a good model, then we can store it into the pluggable application. That is the reference. So after you have the reference, this reference is what? Is this one. This one here. we need to train it. We need to have a model, put it here. So after we have this model, then after you have correct data and in running, then this is the running data shown here and compare with the reference. Then we will know what's going on. We will know the system is healthy or not. So you see, this is running. During running, because we have already got a reference here, right? So if we correct data and compare with the reference, and if good, then don't worry. Then if not, then you need to send alarm. You see, you send alarm to the host, right? So that is the scenario. So you see, so the training phase, this is training phase. I just explained it already. Collect the healthy data and put it in the pluggable application module. Then you see the training phase, the sense state. After you see this 1, 0, 0, 1, that is the photo sensor on and off. So you see, if this is just a healthy run, then this pattern should be recorded as the reference. Okay, and you see the training phase. So you see, we will collect data and send it to the host to edit it, to check that this is healthy data or not. If yes, then of course, then put it into the PAM to be the reference model. Then after run, then during running phase, then of course we need to collect data and then compare it with the reference, right? It's collect data and go to here, right? And sorry, collect data, go to here and then compare with the reference and check it to see what's going on there. And if something wrong, then report it to the host. Okay? So then, if necessary, we can send an emergency stop. That is a whole lot. If really equipment has something failed, then you cannot let it to run again, right? So you need to stop the machine immediately. So you will have emergency stop signal to stop the conveyor. Okay, so you see PMS function, we can detect the sensor fault and the motor fault. So you see, let me show you what's going on here. Okay. So you see the data shown here. The data shown here, that is the motor. Encoder, that is means speed, and the current. So you see the sensor. This is the on-off sensor. Okay. So this sensor fault detection. 那被我按到了，不好意思。You run one more time. Okay. So you see, it's conveyor. This is the real data we recorded from the real control panel. So after detecting that the sensor is fault, then the sensor will have a red light on. Okay, sensor fault detection. Just a second. And 这个那个谁。今天就到这边，等一下。